Willkommen zurück, Hamburg! I hope everyone had a good sleep and is ready for another fantastic day. And I'm going to move swiftly on. If you remember from yesterday, you had just fallen and you're falling through the air. The air swooshes by and you think that this is it, this is the end. But in the distance, you see 3 black dots. Valar Morghulis, you hear, and a blonde woman swoops in atop a dragon. Another dragon flies in, and atop its back is Will from House Postgres. The dragon swoops in, and you realize that as it falls in, your jewel from yesterday has disappeared. Daenerys Targaryen flies off into the distance, taking her dragons with you, and you and Will fall again, crashing through the roof of the church.
Hello. My name is Will Leinweber. For the last nearly 5 years, I've worked on the Postgres team at Heroku. But before we start, I really want to say thanks to the conference organizers. This is just such a great event. Thank you very much. And the second thing before we get started is, so I've done a lot of stuff with Postgres, but lately I've been really enamored with this new programming language called Crystal. And I normally don't like new things, so it's really weird that I like this. And this is just an example here of a minimal Postgres driver in the first 6 lines, and then the last 3 lines are using that to execute a query. And you can just drop this one file in and run it, and it will link against libpq and execute the query. And I think that's pretty neat. I thought briefly of switching my entire talk to this, but I thought that'd be a little unprofessional. So on to sort of the overview of what we're going to talk about today. So one of the fortunate things about being with Heroku Postgres is I've been able to see a bunch of different people using Postgres all along the line, from just starting, customers who are just starting out with Postgres for the first time, to people who have used it for years and years, people who have very small data sets, and people who have very large things, and seeing all the different things they get to use and all the different problems they have and so on. And originally when I was putting this together, I envisioned the talk being a bunch of tips and tricks. And I could easily fill a 2-hour talk on that. However, what I thought would be more appropriate for this audience is more of some things I've noticed over the last 5 years and working with all these customers. And the first thing that you have to know is that Postgres is very old. I think just last month it turned 19, which for a technology in this day and age, like that's positively ancient. Now, to be fair, a large part of that was spent as research projects in various universities, and then a long time after, really as not used a whole lot, but had some following. Really about, I would say, 6 or 7 years ago, whenever Postgres 8.3 came out, is when they really started to pour on the steam, and every release got better than the last. It got faster and faster, more features. And the other thing with a system so old, for better or worse, it really seems that SQL's not going anywhere. SQL is a terrible language. I mean, it's ugly. It's hard to work with, but it's the interface to these extremely powerful systems. Part of the thing with Postgres being so old is that there are a lot of great features there, but you kind of have to really know where to look. You have to you have to kind of know what you can do before you find out how to do it. And so as part of this talk, I want to show you some of the things you can do, but also sort of illuminate your path to so you don't stumble into any pitfalls along the way. So I imagine many of you here have probably used Postgres, but if you come from a similar background to where I started, you probably are using it with something like Rails or Django, and they really want you to, sort of the philosophy there is to treat the database as a, sort of a dumb black box. And so many of the customers who first come to us with, that I've seen, aren't really taking advantage of all that's there that's powerful, which is a shame because there's so much under the surface. The other thing that it took me a while to realize, but going to Postgres conferences and meeting more traditional proper DBAs, whenever the topics of ORMs come up, they would always just sort of an automatic sneer or just start hating on them right away. And coming from my background prior to this as a Rails developer, I was always kind of taken aback. I'm like, there's ORMs are very useful. I get a lot of value out of them. Why are you dismissing them so much? But it took me a while to realize what the actual problems are. So the main goal of an ORM is to abstract away all the nasty parts of SQL, the nasty inconvenient parts of working with a relational database. But we all know that abstractions can be leaky, and so even the best ORM that I've seen really can't abstract everything away. But on the other side of the fence, there is a lot of value you can get out of using them. So that just because they're leaky, that's not really the problem. And so that was my first thought of why DBAs tend to sneer so much at ORMs. But recently, only in the last year or so, I've come to realize that I think it's a case of misaligned incentives between the authors of these ORM frameworks and us as a user of them. So both of us, developers and the ORM authors, we have the same goal of we want a nice interface in front of our database. But the ORM authors have a secondary goal of wanting as many as many customers or users of their platform as possible. And to do this, they have to cater to the least common denominator between all the different databases, Postgres, MySQL, Oracle, SQLite. Any feature that's not in all of them tends to not make it into these ORMs. And that's not so bad. But what I have started to take a little bit of offense to, or a little bit of maybe not offense is the right word, but a little caution about, is that they sell this feature of being able to support any ORM as the ability that you're going to be able to switch out your production database at any time. But I almost never see anyone actually doing this and not having to, at the same time, change large swaths of their application code. And it just doesn't happen that much in general. But in the cases that it does happen, the reason that people have to change, even with their ORM, a bunch of application code, is that a bunch of unexpected and inexplicit reliances on how their underlying database is doing things leak up into their code. One specific example of this is MySQL by default will do a lot of type coercions, and also if you put in a long bit of text into something that's only supposed to have like 10 characters, it'll just silently truncate it, whereas in Postgres it will throw an error. And these sort of things leak up. So all of this talk about ORMs is just to say, don't be afraid of coloring outside the lines and going outside of what the boundaries of your ORM is to use some of these advanced features that are in your database. Before we get into some of the more things I want to talk about, a common pitfall that people run into, before you can understand it, you have to understand how Postgres deals with concurrency under the hood. And this is something that a lot of people run into head first and then have to go back and learn about. So I want to share that with you now. So MVCC stands for multi-version concurrency control. Postgres isn't the only database that uses this. I know CouchDB and some others use it. But basically what happens is whenever you go to update data, modify data, or delete data, it doesn't actually change what's already there. It just, because the old data stays there, when new readers come in, they can read the old data, and writes don't have to block concurrent reads. And the way it does this is that on every single row, there's a number of hidden columns that you don't get when you do select star, two of them being xmin and xmax for the minimum transaction that it's visible in and the maximum transaction that it's visible in. And so when you go and delete a row, all it does is set xmax to the current transaction. And that's all well and good, but the problem that people run into is what is referred to in the Postgres community as bloat. Because all that dead data is still sitting around, it's taking up space. Indexes have to scan through it and skip it. And this can cause some problems. There's a command you can run called vacuum, which will clean that up on demand. But Postgres also has an auto vacuum that goes in and cleans stuff up for you. The problem with auto vacuum, though, is it is pretty passive by default. And so if you have a table that has a lot of churn, a lot of updates to it, it can become bloated much more quickly, and auto vacuum maybe can't take care of that. The good news is you can tune auto vacuum to become much more aggressive and take care of the bloat problem. The other common case of bloat that I see very frequently is long-running queries, because if you have a query that's been running, a runaway query that's been running for a day or two, Postgres can't clean up the old records that are there because potentially it's visible. And so these are two common problems that I see a lot of people run into that isn't so great. So now getting into, this is my favorite part of Postgres is the fact, and I think it's the core strength, is the fact that it is so much more strict about constraints than many other databases. And now this can be frustrating to new users. I see a lot of posts and stuff of complaints of things don't work the same way that they're expected to, and Postgres is throwing a lot more errors. But these constraints, I think, are really sort of the saving grace of databases. And so I really strongly believe that you want your database to be the last line of defense for things that can go wrong. Of course, it's terrible if your application is offline and throwing lots of 500s, but that's an acute problem that you can fix. Much more insidious, I think, is when you get bad data or mangled data into your database over the course of weeks or months, and you only notice it after everything has been ruined. In that case, maybe you have backups, but you have to go so far back to clean it up that it's can just be a catastrophe. This might be biased from working with Postgres or database team for so long that I think this is the worst problem, but it can be pretty bad. Looking at it another way, if you assume that every time you make a change, every time you update your code, every time you make a new patch, you have the same % chance of introducing a bug. Outside of the initial development of a new application, changing your application code, that happens orders and orders of magnitude more frequently than changing the schema of your database. So if you can get the schema locked down and you can get a lot of hard constraints on the data portion, that'll save you from accidental bugs when you're changing your application code so frequently. And so to start off with an easy one, I'm sure many people here know that if you're doing a unique constraint inside your Rails ORM or something, it doesn't have enough information without doing really heavy locks to actually ensure that things are unique, so you want to put that in the database. But more interesting is that Postgres allows you to have partial indexes. And this works for both lookup indexes and unique constraints like this. A very common pattern that I've seen is people don't actually delete data, like delete users or delete records, and they just set a deleted at flag. If you just, the second part there where you say where deleted as null, you can still enforce a unique email address for everything but the deleted stuff. And this is very useful for both the unique constraint, but also if it keeps your indexes much smaller and much faster to use. Even better is the ability to do multi-column unique constraints. And so I worked on a project called Telex there, and it's actually open source. I don't think much people would get value in running it themselves, but it's a good example of a Pliny app. And Pliny is a API toolkit that our API team released for developing APIs with Sinatra. And it'll take care of JSON schema. It'll take care of migrations. It has like a nice mediator interactor pattern built in. So if you're working on an API, I encourage you to check out Pliny. And if the documentation is non-existent, so having an example app helps a lot. But anyway, in this app, what it does is different components throughout Heroku, they can, instead of each team having to reinvent emailing users, they can use this service to, it sort of consolidates all the notifications of users. And so if you think about the problem, a component either wants to notify a single user or all collaborators on an individual app. And so because of this, there's a many-to-many relationship between the messages that these producers are sending and the users. So the application is simple, and when I was writing it, I'm like, there's no bugs here. This is obviously perfect code. But I went in and put in a unique constraint on the set of both user ID and message, and that way there can only be one notification that actually goes out to the customers. And I put this unique constraint in just as a safety check, and sure enough, like a month or two in production, I started getting a couple emails from the exception tracker saying that this constraint would have been violated. And it happens rarely enough that I haven't gone and tracked down the cause of this race condition, but whoever those handful of customers were, they got their inboxes saved by this unique constraint, so that's nice. So this next part, I think, is the most important constraint, and this applies to not just Postgres, but any database. The SQL standard got a lot of things wrong. One of them, I don't think, if you have an update or delete and you don't say anything on the where, it shouldn't do the entire table. Like, that's just crazy. But the other thing is when you create a new table or you create new columns on it, you have to opt in to saying that you don't want nulls in there. It should definitely be the other way around, where you have to opt into having something nullable. Because even if you think your application is behaving correctly all the time, mistakes happen and nulls get in there. So for those of you who have a relational database on your application, the homework I pose to you is to go and look through each of your tables and look through each of your columns. And if you think, this email address, there's no reason for this to ever be null, go ahead and alter your table and add that not null constraint. I bet that you'll find a couple cases where there's surprise nulls when you didn't expect it. And you're going to have to clean that up. But you'll be in a much better place afterwards. So one of the things that is also very nice about Postgres is they have a lot of different data types to choose from. And this is a form of constraint also. So for example, one of the ones that I use a lot is the Uuid column. And what this lets you do, instead of just having a text column, it enforces that it's actually a proper Uuid with like one of them has to be like the number 4 if it's a version 4 UID, and like another one has to only be an 8 or above, and so on. But it enforces everything to be a very proper UUID, and that's nice. And on top of all the regular ones like numbers and booleans, text, and whatnot. But even if there isn't a data type that meets your needs, you can you can make your own sort of like constraints using what's called a check constraint. So on our application that does all the monitoring and provisioning of databases, of course, because security conscious, we encrypt all of the passwords and usernames to the database, the passwords to the database, and the connection strings, and so on. But we're constantly decrypting them to go in and do health checks on the database, and then and so forth. We started running into this weird problem where, like, once a week, there would be another database that would pop up that we wouldn't be able to decrypt the password to. And so what we'd have to do is generate new credentials so that we can continue to monitor the database. But we couldn't figure out what was causing the problem. One of my colleagues was mainly working on this, and then after a couple weeks, because it just didn't reproduce frequently enough to be able to track it down, I went and I looked at just the ciphertext of all these passwords that are encrypted passwords that weren't working, and I noticed that on all the ones that didn't work, there was a lot of 3s, and that struck me as kind of odd because I would assume that proper ciphertext would have sort of a uniform distribution of characters. And then also looking at it, the ones that weren't decryptable were also much, much longer than all the other ones. All of our passwords are like a uniform length, and so seeing some of them where they were so much longer was pretty weird. So we went ahead and put in this check constraint and a number of other ones that would prevent the writing of this bad data just based on size. And what this did is it moved the error from when we were decrypting it later and time shifted that back to when the error was being put in. And before this, we tried many things to try and track it down, like before writing it to the database, decrypting it in memory to make sure we were writing what was there, but none of it worked. But this, once we moved the problem to be an error on write instead of later on down the road on read, we were finally able to, with the help of Jeremy Evans, the SQL maintainer, track it down to a small bug in the C driver for Postgres. And we were finally able to track it down. And so this sort of ability, as long as you have these hard constraints to move the error, to notice it when it's happening rather than just the effects of it later on, is extremely useful. So my favorite data type, by far, is JSONB. JSONB came out in the most recent version of Postgres 9.4, but there's been a JSON column for the previous 2 releases. But really, the history goes way back into the 8.2, 8.3 days with HStore. So HStore is a column that is sort of like a Perl dictionary, but as a column. So you can have a key value store, but the downside is that the keys can only be strings and the values can only be strings. And so if you want to do any, have any more advanced data structures, you kind of had to cast it yourself. The other downside to HStore is you couldn't nest them. And so HStore and a couple of the advanced indexes are built by a group inside the Postgres community known as the Russians, because they're Russian. And so they work out of mostly out of Moscow University, but they do a lot of really cool stuff. And so for a while they were working on HStore 2, and this would be allow HStore to have numbers and booleans, have arrays, and be able to nest it. And at some of these conferences, we're like, hey, this is pretty much JSON. How about you use JSON? They're like, no, we like HStore 2. We're like, OK. All right, so we finally were able to convince them, sort of at the last minute, feature freeze for 9.4, to still use all their machinery for HStore 2 that they've been working on, but give it a more friendly developer-friendly JSON interface. And so the B, it actually stands for binary, but I like to think it stands for better. So one of the things that you can do with with JSONB is I was working on a project recently that had sort of an access control list represented here as these JSON things where the star means anyone can read, but not anyone can write. But me, Will, I can read and write, and my team can read and write. But these other documents in here have different permissions. And Postgres has a type of index called a GIN index, which stands for a generalized inverted index. And if you give it this special, poorly named, maybe it's named fine, but hard to remember name when you create the index, it'll create an index that actually has every single key and every single nested key in all of the documents. You don't have to pre-say which things you want lookups for. It just indexes everything. And this actually turned out extremely well when doing the access control lookups. Like, I was actually surprised at how well it worked. And so here, I'm doing a query that I'm looking up where anyone can read, where I can read, or my team can read. And Postgres is smart enough. It can use as many indexes as is available. And I'm not going to go into, for time reasons, like how to, also because it's kind of boring, how to read and explain. But you can see here, all the way the indented part, it is it's running that index 3 times. It's combining them as a bitmap. And then all the cases that could have been false positive, it manually rechecks them, and then it's able to return the query. And so in the example here, I put in, just for testing, I put in 2 million of these documents, and it was able to find the ones that match the access control list in 0.08 milliseconds. And so it was able to scream through all that semi-structured data, which is really cool. But the real power of having, being able to mix a document data store and a relational data store together is that you can start taking advantage of both of these models together. And I've been able to take advantage of this sort of approach for most of my time working with Postgres, originally with HStore, and now that Postgres 9.4 is out with JSONB. And I just got to say that it's just an incredibly productive environment when you have all of your tables that have your relational data and those parts of your application that make sense for relational data, and then the parts that, parts of your application that can have, more attributes that change shape over time. You can have that in your JSON column, but you can have them all in the same table. And this lets you go back and forth between those. And what this really allows you to do is start out with an experiment. You don't know if, you don't want to go through all the whole hassle of creating a new column. You can just throw something into one of these JSON documents, and then, a year later or so, when you go through and you start noticing that, really all of my records here, they have this key, you can lazily promote that into, more of a real column, and then start taking advantage of all the constraints and enforcement and consistency that you can expect from, regular schema'd thing. And and that's mostly what I wanted to share with you about Postgres. I have, many, many more things I can share. So if you're interested, please come up to me, after the talk, or hit me up online afterwards. So thank you very much.